Hi there, it's Matt here, and welcome back to the podcast. I want to start with a fundamental statement. Sleep is not the absence of wakefulness. Sleep is far more than that. What I mean is that sleep is an incredibly active state, demonstrated by the fact that numerous functions of your brain and also numerous functions of your body are restored by, and in fact critically depend upon, the presence of you getting sufficient sleep. Now, of the many benefits to your brain, sleep's role in boosting your learning and memory abilities is both particularly impressive and especially well understood, because we've now discovered that sleep is important for memory in at least 3 different ways. First, we need sleep before learning in order to prepare the brain for the initial formation of new memories. Second, we then need sleep after learning to cement those new memories within the brain. And third, and something that we've already covered in our series on dreaming, sleep also not simply strengthens individual memories, but sleep will intelligently associate and interconnect new memories together, therefore offering the ability for creativity and ingenuity. And in the next several episodes, I'm going to unpack all of these sleep and memory secrets. Today, we're going to focus on the first of those sleep-infused benefits. Namely, I'm going to tell you about the need for sleep before learning to refresh and restore your brain's neural ability to make new memories. It all starts while we're awake. Your brain is constantly acquiring and absorbing novel information, intentionally or otherwise, by the way. And different types of memories are imprinted in different parts of your brain. When it comes to what most of you think of as memory, which is what we call fact-based memory, or you can think of it almost like textbook-like learning, such as memorizing someone's name or remembering where you parked your car last night, sometimes fails me. That type of memory, that fact-based informational memory, critically depends on a long cigar-shaped structure that sits on the left and the right side of your brain, and it's called the hippocampus. And you can think of the hippocampus almost like the informational inbox of your brain. It is very good at receiving new memory files and holding on to them. Perhaps a different way of thinking about the hippocampus is almost like a USB stick. It's very good at acquiring lots of different files from different locations. But an important part of that USB stick, like the hippocampus we believe, is that it has a storage capacity limit. And we'll come back to why that's important in just a second. The podcast is supported by Masterclass. Masterclass is an online streaming platform where you can learn from the world's best on topics such as cooking, business, art, entertainment. There is writing, sports, science, there's health, technology. It's a big span. And you get access to people such as Martin Scorsese, Venus Williams, there's Gordon Ramsay, I think, Steph Curry, the basketball player, Neil deGrasse Tyson, wonderful scientist. Even Bill Clinton is on there too, to name but a few. You may even find a masterclass from a familiar sleep scientist on there as well. And just a note, this holiday season, Masterclass are going to do a give one annual membership and get one for free offer. So go to masterclass.com/Matt Walker today. That's masterclass.com/Matt Walker, and you can start exploring your journey. Some years ago, my research team and I decided to conduct a study focusing on this part of the brain, the hippocampus, and we asked a very simple question. Is pulling the all-nighter a good idea? So we recruited a group of perfectly healthy adults and we assigned them to one of two experimental groups, a sleep group and a sleep deprivation group. Now the sleep group, they got a full 8 hours of sleep opportunity, but the deprivation group, we kept them awake in the laboratory under full supervision. There were no naps, there was no caffeine, thoroughly miserable for everyone involved. And then the next day, we placed all of those participants, one at a time, inside an MRI scanner. And we had them try to learn a whole list of new facts as we were taking snapshots of their brain activity. And when we compared those two groups head to head, the first thing that we found was that there was a significant 40% deficit in the ability of the brain to make new memories without sleep. I think this should be perhaps at least a little concerning, considering what we know is happening to sleep in our education populations right now. Just to put that in context, it would be the difference between acing an exam and failing it miserably. We then went on to discover what was changing within the brain to produce those types of learning disabilities. And when we looked at that structure, the hippocampus, where we initially encode those new memories, in those people who'd had a full night of sleep, there was lots of healthy learning-related activity. Yet in those people who were sleep deprived, we actually couldn't find any significant signal whatsoever. So it was almost as though sleep deprivation had shut down your memory inbox. And any new incoming files, they were just being bounced. So you couldn't effectively commit new experiences to memory without sleep. Or using our crass computer analogy, and it really is just that analogy, it was as though the USB memory stick within the brain was full after a day of acquiring new files. And therefore, once you got past that 16 hours of storage capacity, which is the amount of time that we're normally awake, there was no more room left. And therefore, you couldn't imprint any new memories into the brain. You couldn't store any new files within that hippocampus USB stick. And I should note, by the way, that other scientists working with rats have since discovered that when the brain is deprived of sleep, the individual cells within that memory structure, within the hippocampus, can no longer properly form strong connections from one cell to the next to the next. And that is in part how we think we form new memories, how we encode new information into the brain. And so in those sleep-deprived rats, it's almost as though the neurons of their brains were refusing to imprint information within their synapses when they hadn't got the sleep that they need. And the technical term for this, by the way, would be a failure of what we call long-term potentiation within the synaptic connections between those brain cells. Oh, and I should also note, by the way, it doesn't take the extreme version of an entire night of sleep deprivation to produce these types of learning impediments. If we just selectively deprive human beings of deep non-REM sleep, we can produce exactly the same impairment in both brain activity within the hippocampus and the same impairment in their learning ability the next day. So that's the bad that happens when you're not getting enough sleep, when I take sleep away from you. But let me just come back to that control group for a second. Remember those folks that got a full 8 hours of sleep? Well, here we can ask a very different question. What is it about sleep when you do get it that is so physiologically necessary for enhancing your learning and memory ability each and every day? And by placing electrodes all over the head, what we've discovered is that there are big, powerful powerful brainwaves that happen during that very deepest stage of deep non-REM sleep, what we call these slow waves, which have riding on top of them, almost like surfers, I suppose, these spectacular synchronous bursts of electrical activity that we call sleep spindles. And it's the combined quality of those deep sleep brainwaves that act almost like a file transfer mechanism at night when your head is on the pillow. And it's one that we're going to discuss in great depth in our next episode. But coming back to our story of needing to sleep before learning, we at the Sleep Center wanted to know even more about the process. We wanted to know more about how your learning capacity and your learning ability changes across a waking day and how sleep modifies or restores that. So we designed a new study, and specifically, it was a daytime nap study. Once again, we recruited a group of perfectly healthy individuals, and they were randomly divided into one of two groups, a nap group and a no-nap group. Now, each of those two groups performed 2 learning sessions across the day, separated by 6 hours. So, in the first learning session, which happened at 12 noon, in other words, all of the participants underwent an initial study session where they tried to learn a large list of facts. They tried to cram a list of facts into their memory, into that structure that we call the hippocampus. And, as expected, both of those groups learned those facts efficiently, and both of them learned them to a similar degree on average. Soon after that first learning session at noon, the nap group took a 90-minute siesta-like sleep opportunity in the laboratory that we recorded with electrodes placed on their head so that we could measure their sleep. While the no-nap group, they just remained awake in the laboratory and they performed menial activities such as browsing the internet or playing board games. And then came the second learning session 6 hours later. So now at 6 p.m., all of those participants, as I said, they performed a second round of learning. And here they tried to cram in a completely new set of facts into the hippocampus. Our question, again, was simple. Does the learning capacity of the human brain decline with continued time awake across the day? And if so, can sleep, and specifically a nap, reverse the saturation effect and therefore restore learning ability? And that is exactly what we found. The other supporter of this podcast is the electrolyte drink company called Element. Now, it's actually 4 letters, LMNT. I am a bit of an exercise fanatic, and I started buying their products some years ago, really, because of 2 key facts. First is the lack of sugar content. Element has no sugar. It also has no colorings, no artificial ingredients, which is unlike many of the other mixes out there that I was shopping. The second is because of the founders, who have some serious years of biochemistry experience under their belts, and they know what they're doing. So if you want to give it a try, just go to drinklmnt.com/Matt Walker, and you will get 8 free sample packs on any order that you place. Once again, that is drinklmnt.com/Matt Walker. Those who were awake across the day became progressively worse in terms of their learning capacity at that second session relative to their first session. And by the way, this wasn't simply just an issue of their attention or their focus starting to fade later in the day, because we also measured those things, and they actually remained perfectly stable across the day, at least across that 6-hour period. But in contrast, those people who got the 90-minute nap between the 2 learning sessions, they showed no such decline in their learning ability. And if anything, their capacity to memorize facts was increased after the nap at that second session relative to that first session. How big of a difference was there between these two groups? Well, it wasn't trivial, at least. At that second session, those who napped showed a 20% learning advantage relative to those who remained awake. And finally, I should note that we once again analyzed the electrical brainwaves of those people in the nap group, and once again, we found that it was those powerful bursts of electrical activity called sleep spindles that were occurring during that non-rapid eye movement sleep that predicted how refreshed and restored their ability was in terms of memory encoding capacity. Oh, and just as an aside, please don't get worried about this time of day issue and trying to perfect your learning across the day and building in naps. We'll also speak about that later on. And what I should note is that independent of sleep, we know that different people learn more or less efficiently at different times of day. And this is in part because of something we've discussed before, which is based on your levels of alertness and also based on your chronotype, morning type, evening type, or somewhere in between. So then, taking stock, what have we learned in this podcast today? Well, one function of sleep for humans, and in fact we've now discovered for many different species, and it is a critical function at that, is to prepare our brains each and every night so that when we wake up the next day, we can efficiently learn new information. And that process cycles over and over again, learning during the day, restoration of learning capacity at night. And like a sponge, without sufficient sleep, our memory circuits effectively become waterlogged, as it were. So we can no longer absorb and soak up new information. We can't make new memories effectively. So that's the role of sleep before learning. In the next episodes, we're then going to discuss perhaps an even more remarkable set of scientific findings, which is that we need sleep after learning to consolidate and cement those freshly minted, those newborn memories within our brains. And with that, I will say good night. It was lovely to have you along with me for this episode. I will see you next time, and goodbye for now.